The Internet of Things is becoming a reality. Factories are being outfitted with sensors, temperature monitors, and other data gathering devices. In agriculture, farms are becoming more efficient thanks to soil monitoring devices and automated pesticide regulation. And in our homes, refrigerators and alarm clocks and mirrors and Nest thermostats are becoming smart. Today, Steve Busby joins the show to talk about the big picture of IoT. How does it actually work? From data ingestion to processing to feedback. How do our systems ingest the data that we are producing and respond to feedback that is calculated? Steve works at Microsoft in the Azure IoT division, and he discusses the problems that companies are having and the solutions that are available today from our IoT infrastructure. He also discusses where we are going in the future and how long it's going to take till we get to that big IoT dream that we've been talking about for so long. If you enjoyed today's episode, please share it on Twitter or Facebook, or tell your friends about your favorite episode, or you can send me an email at softwareengineeringdaily@gmail.com to give me some feedback. I'm always looking for new show ideas. I want to know what you want to know. So thanks for listening. I had a crazy idea a couple weeks ago. It's a photo sharing app that only has pictures of cats. When I finish my photo sharing cat application, I will be deploying it to Linode because Linode is the fastest hosted Linux provider. I don't want to get locked into a proprietary platform that's going to overcharge me as soon as my app gets popular. I just want a fast Linux server with simple pricing. Go to linode.com/sedaily and get $20 in free credit today. Plans start at $10 a month, so my free $20 will be plenty to launch my cat photo sharing app. Once I need to scale, I can use tools like node balancers and backups, and Linode has built-in dashboarding and metrics so that I can see the traffic to my Linode servers, and I can understand how many of my users are posting cat pictures and looking at each other's cat pictures. Go to linode.com/sedaily and get $20 in free credit today. The plans start at $10 a month, so it's a great deal. Thanks to Linode for sponsoring Software Engineering Daily. Now let's get on to this episode. Steve Busby is an Internet of Things technology specialist with Microsoft. Steve, welcome to Software Engineering Daily.
Thank you. Appreciate it.
How do you define the Internet of Things?
So generally, lots of people have lots of different ways to define it. Typically, we really just define it as with really four aspects: the things themselves, the connectivity of the things themselves, a place and a way to store the vast amounts of data related to events that the things send, and then the analytics, and really in increasing value of that from left to right. So the things are obviously valuable because you have to have them. The connectivity is valuable because you have to get the data. But from a business value, it's typically much more valuable in the storage of all of that data, and more importantly, analytics and action. So I don't really have a concise, one sentence definition.
The discussion about the Internet of Things has been going on for so long. It seems like since the early 2000s. And every year it seems like we're around the corner from finally realizing the dream of Internet of Things. What has been stopping us from making IoT a reality?
So I think the primary things that have been stopping us, or kind of another way to put it, the things that are enabling us now that we didn't have in the past, were the thing. It's really, I think it's a convergence of a number of things. One is that the things themselves are getting both cheaper and more powerful. So the ability to have a small but just very powerful computer that's either single digits or low double digits in cost. I think connectivity, while it's not completely ubiquitous, certainly it's more pervasive, and it's cheaper than it has been in the past. And there are more new options as well for connectivity beyond just the traditional Wi-Fi or telco providers, with things like Sigfox, for example. for and LoRaWAN and other technologies like that. So, the things themselves are getting cheaper and more powerful. Connectivity is getting more pervasive. Really, I think one of the trends that has definitely helped is with things like cloud computing, the ability to store vast amounts of data from these things, and to be able to do so in a cost-effective manner, I think is one of the kind of key trends that's helping IoT realize part of its promise. And then finally, really the last thing that I think is really one of the biggest keys is the ability to do analytics on that data. So I think with the emergence of big data type technologies like Hadoop, as well as machine learning specifically, and artificial intelligence is really helping people take advantage of that data. So I really think it's kind of a convergence of those four trends that has held us back in the past, that's really enabling us to move forward now.
What are the things that people are actually connecting these days? Do you have any interesting real world examples that you've seen?
Yeah, absolutely. And I think some of them are pretty interesting. I think a lot of the things you'd expect people to be connecting are traditional things like machines on a shop floor, or smart meters, pieces of equipment on oil rigs and drilling installations and those kinds of things. But the interesting thing and the really fascinating thing about IoT, and particularly what we've seen from my role, is the wide variety of things that people want to connect. So, for example, I recently had a discussion with a customer about what I call the Internet of Dumpsters. So people, this customer wants to connect their dumpsters. They're a waste management type company, and they want to internet enable their dumpsters so that they can tell when they're full or not, when they need to be emptied, and they can kind of optimize their routes and optimize things around that. We have one customer that makes wooden pallets. So these very inexpensive little pallets, but they have to track a ton of them, and they tend to lose track of them from time to time. Another example is we've got I don't know if you've seen or heard of the case study. We've got the connected cow case study. So we've actually got farmers who are trying to predict things like the best time to breed cows based on being able to tell when they're when it would be most successful to help breed that cow. So it's kind of interesting, the vast array of things that people want to connect. But I would say most of our opportunities are generally around manufacturing. Healthcare is really a big one, and kind of oil and gas, and some of the traditional things you'd expect people to connect. But there are some really interesting scenarios out there as well.
So there are many devices that a company might want to connect, like a refrigerator, a dumpster, like you said, a car, an assembly line. Most of the devices that are on these assembly lines or in these companies, these dumpsters, they are what we would call dumb. I think most dumpsters do not have a chip or a sensor built into it. So can we make these dumb devices smart, or do we need completely new devices?
We definitely don't need new devices. I mean, we focus very much on helping customers enable existing devices. In fact, the marketing tagline for Microsoft's Internet of Things solution is we call it the Internet of Your Things. The idea is helping get these existing things connected. So, some of them, as you say, are dumb. So you have to really figure out a way to add a sensor to them, and then potentially have them connect through what we call a gateway. So in some cases, these things are really old, like elevators, for example, that only speak serial. We're working with a company that makes elevators, and they their elevators speak over 100 baud serial cable. Other devices are not necessarily dumb, but they speak protocols that aren't internet enabled, like Bluetooth Low Energy, for example, or Zigbee or Z-Wave or something like that. And in those cases, really we talk about sending that information through a gateway. So we might hook up a device that reads data off the serial port and does a protocol translation of that up to some protocol that we can send to the cloud.
So what kinds of processors do we need to put on these devices that it's like a dumpster. I've got a dumb dumpster. What kind of thing do I need to put on the dumpster to make it a smart thing?
So typically, for most things like that, generally we're looking for some relatively low powered device that at least has internet capability. So the classic example that we use in most of our POCs and early implementations is something like a Raspberry Pi or a Dragon board or Minnow Board Max or something like that that has a Broadcom processor, an Intel or an Intel system on a chip type processor. Generally, those are sufficient for most implementations. Usually, a lot of it depends on requirements. Does it have to be battery powered? Can it be plugged in? Those kinds of things. But there's a pretty broad array of actual processors themselves. It generally just comes down to what type of sensors are needed, and what the power requirements are for the device.
Who's the company that is making most of? So you mentioned Raspberry Pi, obviously for maybe for prototyping or something. But like, if there's some, are there large? Like I've heard of Intel, I think, making processors that are specifically for the IoT. Is there any big companies that are making huge plays on getting their specialized IoT processors out there?
I would probably say there's a bunch of them. Just about every processor manufacturer is making an IoT flavor of their processor. Broadcom is certainly very, very popular choice. There's even custom processors. A company that we work with called iBot. They make a pretty optimized IoT processor as well. Intel is really the big one, as you mentioned. And in addition to just pure processors, a lot of these companies are starting to make gateways as well. So not just a processor, but a gateway that can speak, either industrial protocols or even consumer protocols on one side, and IoT, internet, cloud protocols on the other.
What is a gateway?
A gateway? So a gateway, So gateways generally what we consider a device that sits in between the dumb device, one or more dumb devices, and the internet, and can do protocol translation, potentially edge processing as well. So you might have, for example, we work with a company that makes batteries, and they have customers who have forklifts, for example, just to give you an example, running around their facility, and whenever they charge their forklifts, this company gathers data about the battery from all of these different forklifts, and they funnel that through a gateway up to the cloud. So this gateway, the batteries in the charging stations, they speak a protocol that can't talk to the internet. So the gateway takes that data, does a protocol translation, and sends that to the cloud. And that can work both ways as well. We can send commands back down to these devices via the gateway, and have that gateway do their protocol translation in the opposite directions. Really, typically gateways are used for two or three things. One is protocol translation. So maybe I've got one or more devices internally that can't talk to the internet. So it does that protocol translation out to one of the protocols that we speak. For example, for Azure specifically, it's either AMQP, MQTT, or HTTP. The gateway may also do edge processing, so it might do some local filtering. So, for example, if I've got a whole bunch of data coming off a dumb device, but I only want to send a subset of that, maybe it's just alerts and alarms up to the cloud, I can filter out a lot of the noise and send just what I want up to the cloud. Or maybe I want to do aggregation, local aggregation. So maybe I've got a device that sends data once a second, because that's what it's done for the 30 years it's been in existence, to send data once a second over the serial port. But I only want to aggregate that data and send the aggregate up once a minute to the cloud, or once every 5 minutes. So the gateway can do that processing as well. And then finally, a lot of people look at gateways as a security boundary as well. So I want to essentially NAT my devices behind this gateway so that my devices themselves aren't connected to the cloud directly.
Yeah,
So
let's talk a little bit about that.
Yeah, okay.
Let's talk a little bit about that security, because there are these kinds of devices that we don't maybe want connected to the internet because security is such a high priority. Like if I have a heart rate monitor or a nuclear power plant, I'm not sure I want to be connected to the internet. So you're saying that a gateway can help regulate the traffic and prevent some of the malicious potential situations.
Yeah, exactly. I mean, the gateway, it can be used to kind of hide the fact that there are devices on the private side of it. It certainly reduces the footprint, the hackable footprint, certainly from these individual devices, many of which were never designed to be connected to the internet, so they're not secure in any way, form, or fashion. And even the ones that have been hardened, it's just defense. It's just a defense in depth mechanism for being behind the gateway. And certainly the gateway gives you kind of one place to focus your efforts in terms of hardening the solution as well.
So as we start to talk about using this Internet of Things, we should talk about the information that's actually coming off of these things, or how it's being coming off of them and then being translated by the gateway, perhaps. So the information that is coming off of these things, it might be in the form of events or perhaps time series data. What is the typical schema for something that is coming off of an Internet of Things device? What is the schema for an event or a piece of time series data?
So generally, so the schema in terms of what information is included in the event can is very wildly varying. It all really all depends on exactly what it is you're trying to monitor. I mean, certainly temperature and vibration are popular in some areas around things like motors, temperature, vibration, even noise. You tell when a motor is going bad because of noise. Certainly for health devices, it might be heart rate and skin temperature and things like that. Generally the actual content of the messages varies pretty wildly by industry and by application. In terms of protocols, in terms of formatting of the messages, the schema of the messages in terms of formatting, you often see things like JSON or CSV. You see Avro from time to time, but I would say JSON is by far the most popular, particularly for any new, not necessarily a new device, but for any new implementations of IoT, particularly one that does do some type of protocol translation. JSON's been by far the most popular format of messages, but the schema itself can vary pretty wildly. Mm. And there's some, particularly in the consumer area, there's some efforts at standardization, such as the All-Seen Alliance and All-Join implementation and those kinds of things. And there are different standardization efforts even on the industrial side for things like OPC and those kinds of things. But there's still the interesting thing about IoT standards is there's so many of them. Yeah.
Okay. So let's say I have all these events coming off of my Internet of Things platform. It's either coming directly off of the devices and into the internet, or it's hitting the gateway. The gateway is forwarding them to the internet. How is data getting ingested by my cloud provider? So, I mean, you work for Microsoft. You have the Azure IoT platform. So the data gets ingested, and then you can do all these different things with it. Let's first talk about the ingestion layer. How is that data coming in?
Mm-hmm. So for Azure specifically, it's generally coming in through a technology we call IoT Hub. Azure IoT Hub. It's a PaaS service, platform as a service. So there's no virtual machines to manage or any of that. You just turn the thing on and tell it kind of what scale level you're looking for. And want to pay for, or really in terms of what number of messages per day you expect to get. And then we have it's the service that ingests that data, very high scale, high performance ingestion engine. And then to get the data to IoT Hub from the device side, we have a number of device SDKs. for various operating systems and languages and things like that, that kind of help get data to IoT Hub from an ingestion perspective. And in addition to ingestion, the IoT Hub also allows you to do command and control. So it's a two-way communication with the device so that you can send commands back down to the device as well in a reliable manner.
Talk more about the IoT Hub. What is that? We had a show about event hubs recently. I don't know if IoT Hub is closely related to that, but maybe you could just explain what an IoT Hub is.
Yeah, it is, and it is very related to event hubs. In fact, event hub, some people call event hubs kind of the precursor to IoT Hub. That's not really accurate. They're because that implies event hub is going away, which it is not. It is still very much a part of our ingestion story at Microsoft. So the challenge with Event Hub, specifically for IoT scenarios, was there was a few limitations of Event Hub that we needed to address. One was Event Hub is limited to 5,000. A given Event Hub is limited to 5,000 concurrent connections. So obviously that's not going to cut it for large device count implementations. The other limitation was it was single security, meaning that you did not do per device authentication. So you kind of had that one authentication key that you said you're either in or out in terms of talking to the hub. And then the third thing was it wasn't bidirectional, so there was really no way to talk back to the device. It was for ingestion only, and we still use it a lot for maybe cloud to cloud or even data center to cloud type ingestion scenarios. But what we did to address that was we created IoT Hub. So IoT Hub is meant to address some of those limitations of Event Hub, and it's really a very related technology. But it does address those things with per device authentication. With we've tested it up to 10 million concurrently connected devices per hub, and we've also, as I mentioned earlier, enabled the bidirectional communication through the hub. So it's a very related but kind of much more IoT appropriate technology.
Yeah, so in the Event Hubs episode, we talked about how IoT Hub was somewhat similar to Kafka in that it's a distributed pub-sub replicated buffer of messages, and it makes a lot of sense for the ingestion layer because you have all these events coming in. They get buffered on the Event Hub or the IoT Hub and can gradually be ingested by your system. They can be pulled into your system, and in the meantime, they remain on the queue that is your message buffer, either your Event Hub or your IoT Hub. So after that ingestion layer, where does my data go next?
So typically, there are a number of places for your data where your data can go. We have code that we've released, an object called Event Processor Host that you can use to do custom. You can basically write custom code and kind of process that data directly in code if you want to do some kind of custom processing, and maybe dump it to storage or do something really custom with it. By far, the most common place for that data to go is a technology called Stream Analytics, which is our real-time streaming engine in Azure. So it's meant for doing a lot of that, the analytics after the data hits the hub, and you want to do what we call it the hot path analytics, where you need to do something near real time with the data. Stream Analytics is by far the most popular next step.
Yeah, we also had a show about that. So give me an overview for how I would use Stream Analytics. What would I do with that with my incoming data? Yeah.
So Stream Analytics, it sounds like you've already had a session on it. Just the 30-second version of it. It's basically a SQL-based streaming analytics tool. So you write really never-ending SQL queries that run across the data as it streams by, and kicks out rows and row sets, as interesting things happen or as you meet criteria. So examples of that might be, I might want to do some type of filtering or alerting. So I can do things with, where clauses in the SQL, like, where temperature is greater than 100, or where, vibration is over a certain threshold. So that's, one interesting thing that you can do is alerting type implementations where you're looking for anomalies, where, some value has bypassed some threshold. Another common thing that you might do with it is aggregations. So maybe you're sending data once a minute from the devices themselves, but for downstream purposes, you really only want, the 5-minute average or the 1 hour average. So you can do things like you can do in SQL, mins, max, sums, averages, counts, those kinds of things. So things that you would typically do in a group by in SQL, you can do as part of Stream Analytics queries. And then the other thing that you can do is look for really kind of temporal based use cases as well. So maybe I want to look at the average temperature over the last 5 minutes and compare that to the same 5-minute period yesterday, or I want to look for the absence of messages. So maybe I'm looking for cases where a device hasn't sent a message in the last hour, as a way to kind of alert myself that device has gone dark on me and that I need to investigate. Or you can even do things like I just got an ending event, a door closed event for a device. I want to look back and see when I got the door open event for that device, so that I can calculate how long the door was open, just as an example. For that kind of analytics. So not only can you do kind of right now type filtering and aggregation, but Stream Analytics gives you the ability to look back temporally at the data as it was in the past. So you're essentially you're taking the stream as it is at the moment, and you're doing a SQL join to the stream as it was an hour ago.
Software Engineering Daily is growing. More than 10,000 people listen to Software Engineering Daily every day, and I take that as a sign that this is something unique that people value. I am expanding the scope of the project, and I want to get other people involved. Send me an email at softwareengineeringdaily@gmail.com. I'm looking for new hosts, and I'm also looking for engineering and design help to help build a better website to host this content. Once I have a better site, the podcast can expand beyond audio content and into written word. If you're like me, you are not satisfied with the quality of material online about software engineering. If you have any suggestions or comments about what you would like to see more of on Software Engineering Daily, what you would like to see Software Engineering Daily evolve into, send me an email. I'm also looking for sponsors. If your company would like to support Software Engineering Daily, please send me an email at softwareengineeringdaily@gmail.com. There's advertising availability, and there's also other ways to support the show. Just send me an email if you're interested. Today, the show is generating enough money for me to make this a full-time job, but I would like to increase the cash flows so that I can reinvest that money into projects related to Software Engineering Daily. It's been almost a year since I started Software Engineering Daily, and I'm incredibly thankful that the listenership and the support has turned this into a sustainable business. If you are ever dissatisfied with the show, send me an email, send me a Slack message, send me a tweet, let me know what I can do better. And as always, thanks for listening to Software Engineering Daily. So with regard to like the temperature example, if I'm getting all these events coming into my cloud it's coming into my IoT Hub from my factory, I've got sensors set up everywhere, and when I process them, when I pull them into Stream Analytics and I process them, I have a sliding window over the last 5 minutes of data, and I find that, oh no, the average temperature of a sensor has gone up extremely high, and I need to act on that data because the temperature has gotten so high. I want to send a signal back down to my factory that says, hey, shut down all of these devices that are generating all this heat because something must be wrong. So is this the type of situation where where the IoT cloud would be a good fit? Because is the latency short enough? Can the signal be communicated down quickly enough before the factory catches fire? Give me a description of if that's a realistic scenario and what would happen.
So a lot of it depends on the requirements. How fast and how much latency you really need. I mean, generally, once the data hits an IoT hub and goes into Stream Analytics, I mean that latency can be as low as a few hundred milliseconds for that data for Stream Analytics to pick that up and take some action on it. But you also have to take into account the amount of time it took the data to get over the internet to the cloud. And whatever Azure service you're going to use to notify somebody. So for example, you can potentially, if it's something that you're comfortable with automating. So I want to, if the temperature goes above a certain threshold, I want to turn around and send a command back down to that device for it to turn itself off automatically. That might be a realistic scenario for something like Azure IoT. If the requirement threshold is such that that you don't want to send a command back down to the device, well, then you have to look at things like Azure Mobile Services or notification hubs, where you're going to send a push notification to a human being mobile device and then have them go shut the equipment down. So I think the electronic part of that can be done pretty quickly and realistically enough for these scenarios. A lot of it just depends on the human factor as well. Now, with that said, we also, particularly through our new Gateway SDK that we just announced, you can certainly do some of that processing on the edge, such that if when milliseconds count, you can potentially do some of that processing at the gateway, and then have the gateway turn around and send a signal down to the device telling it to shut itself off for emergency. So that's one of the reasons that we developed this Gateway SDK is for those type scenarios where I want to do processing locally on a gateway before that data goes up to the cloud, because there might be something that's just that time critical. When milliseconds count.
Ah, I see. Okay, interesting. So when you talk about these gateways, so is this like I've got a server that's just running on-prem that is prepared to do the gateway stuff?
It can be. We do have customers that do that scenario. So for example, we have a customer. And this is actually a public case study. A customer called Ziosk that does. They make the little tabletop things, and if you've ever been to a Chili's or a Olive Garden, the little tabletop Ziosk game thing where you can do your order and those kinds of things. Those things talk to Azure IoT, and they do so through a server that's in the back of the store. But in addition to that, there's also other options for gateways as well. There's certainly, depending on your requirements around how reliable and how hardened this gateway needs to be, things like Minna boards and Dragon boards and Raspberry Pis, they can be used for a gateway. We also have a number of partners, Intel being one, Dell being another, Labellium is another example of one, that are making kind of what I like to call the industrialized gateways. So these are the things that can handle the temperature and the stress and vibration and potentially dirty environments of like a shop floor, for example. So we have partners that are making these hardware gateways that will be leveraging our Gateway SDK.
They are all on-prem, right? Like they do keep these things on-prem because they need to react to the type of situation that we described earlier, where it gets too hot and you need something to be extremely low latency, or you need something that will respond even in the event of a network failure. Exactly.
Yep.
Okay.
Yeah. So all the gateways I've talked about so far are on-prem. We do have a flavor of gateway that runs in the cloud. It's really for a different purpose. So generally, it's for the purpose of I have a device that's capable of talking to the internet, and I'm comfortable with putting it on the internet, but it doesn't speak or can't speak one of the three protocols that IoT Hub speaks natively. Say for example, it speaks CoAP which is another IoT protocol. We have an open source project out there we call the Cloud Protocol Gateway, where we've really implemented kind of the IoT Hub facing side of it. And then it's open source, so people can plug in different protocols on the device facing side of it. So it's a gateway that you can host in the cloud in like a web role or a worker role, and talk to these devices that can talk to the cloud but can't talk to IoT Hub directly. But that's a much more rare scenario than the on-prem, what we call field gateway.
Let's talk more about some failures. So there are all kinds of failures we could discuss. I guess let's start with like the discussion of like your Wi-Fi fails or your connection to the internet fails. Somehow you've got all of these events that are coming off of your devices. You don't want that data to be dropped on the floor. What will happen in that type of scenario? Does it get stored on the gateway, or how does the system respond to that?
Yeah. So today, there's I would say in a couple of ways. I mentioned earlier there are really two ways for devices to connect. One is our client SDKs. So we have these are SDKs that are meant to run on devices that talk directly to IoT Hub. And then we have our separate gateway SDK as well. So I'll address the first scenario first. So our client SDKs, they do a little bit of local buffering. So they do, meaning when you send a message to the cloud, that's not actually a synchronous call. You're basically dropping a message in a queue, and then we have a background thread servicing that queue and sending that data up to the cloud. And it can survive kind of transient network failures. And you have resend logic that can resend that event in the event of a transient network failure. In the event of a full network failure, so I'm down for quite some time, then in that case, typically that's something that the device developer is just going to have to deal with. So they're going to have to persist those messages, assuming they want to keep them. They're going to have to persist those messages locally, and then when they detect that the network's back up, kind of resend them. That's not something our SDKs take care of automatically. It's something we're kind of left up to the device developer. On the gateway SDK side, it's a similar thing. The sends themselves are going to get buffered, but the gateway is going to have to be smart enough to know if it loses network connectivity for quite some time, it's going to have to store that data locally, and that's really kind of up to the gateway developer.
So, we've talked a bit about the ingestion layer and the stream analytics layer. We didn't really talk about what happens if a signal is detected through stream analytics or through some other process, and you want to send a message down from the cloud to your IoT factory, and you want to do something that communicates with those devices. So what is the standard operating procedure for sending a message from the cloud to that network of devices, and how does it make its way to a specific device?
Okay, so there's kind of two scenarios. There's the directly connected device, and then there's the gateway connected device. So generally when something is detected on the back end, maybe through stream analytics or something like that, we'll take that message, we'll dump it in a queue that's being serviced by some code, or maybe either a Azure Logic app, or maybe an Azure function, which is the new capabilities that's in preview now. And that will call an API on the backside of IoT Hub, on what we call the service side versus the device side, to say, hey, I want to send a message to this device. So internal to IoT Hub, that message will get dropped in a device-specific queue, and then will get delivered to the device. If the device is always connected, it'll get it pretty much immediately. If the device is offline, then it'll get it the next time it connects. And get that message and be able to take action on it. Similarly, for the gateway SDK, the gateway SDK is actually what we call composable. It's got kind of a module architecture where you can plug and play, almost like a pipeline of these modules. one of which would be a translation layer that says that allows me to send a message to the gateway and say it's intended for this particular device via its device ID, and the gateway would turn around and route that message back to the correct device. But the gateway itself is gonna get that message from the device queue and then internally route it to the correct device.
So IoT covers a huge surface area, and the different domains of IoT have their own challenges, and I want to go through some of these domains with you so we can maybe touch on some of the unique challenges of these different IoT worlds, and maybe you can touch on other technologies that you need to build on the back end in order to service them. So let's start with the connected home. So the connected home is kind of this nascent thing that's been nascent for a really long time. What are the big challenges in IoT around that connected home experience?
So most of the big challenges around connected home are the multitude of standards, and even within the standards, the multitude of interpretation of those standards to have these devices be able to talk to each other. To have your light bulb be able to talk to the light switch. And those kinds of things. That's probably really the biggest challenge in the connected home. And some of that's technological, and some of that is, of course, business. Right? Everyone in business wants to own the user experience. Everyone wants to be, the hub or the arbitrator of all of that within the smart home. So it's kind of resulted in a little bit of a fractured market. For sure, and having those things talk to each other. There are a number of attempts to fix that. The All-Seen Alliance and the All-Join Protocol is one example of that Microsoft participates in. There are probably others as well. I personally focus much more on the industrial and our corporate side of IoT than the consumer. Okay. But even as a consumer who does home automation, I've seen that myself.
Oh, cool. Interesting. Yeah, I've actually heard about that a lot. Like, your light bulb doesn't have the right protocol to talk to your other smart home device. But since you specialize in the industrial aspects, what about agricultural technology? I've heard of these really powerful soil monitoring systems that allow farmers to track if they've given the right amount of pesticides to their different plants. And this sounds like a really complex problem. It sounds like it's in an environment where the connectivity is not great, since it's, and I can imagine like a huge cornfield. So what are the problems around agricultural Internet of Things?
I would probably say there's a couple of them. One, that you hit on the biggest one, which is connectivity. So, trying to get connectivity across a giant cornfield and to all of these devices, that are typically not only are they separated from each other, but oftentimes they're out in the middle of nowhere. So, trying to get connectivity for those things can be a challenge. The other is also just trying to find devices that will survive in those types of environments as well. So, out in a cornfield that or a wheat field or whatever that's being irrigated every day. So you got to have a waterproof device, but that can also be able to connect externally across the farm. And then the other is power. So you've got to have that same device has to be pretty low powered as well, because nobody wants to go around every couple of days and replace batteries in these things. So it's a pretty classic physically distributed environment issue around connectivity and power, and then just the environment. It's dirty and wet soil, and the things themselves get wet, and they might get trampled by animals and crawled over by bugs. So they have to be very robust.
And with this type of situation, is there anything that Microsoft can do as the service provider, or is this more of a situation where you build the right back-end systems and kind of wait for the hardware to catch up?
Generally, it's mostly the latter, where we're really focused much more on the kind of the Azure side of IoT. I mean, we do make a device operating system with Windows 10 IoT Core, but we really are relying on our hardware partners to provide a lot of this. Now, we do have, a number of partnerships with kind of unique providers that solve some of these problems, like Sigfox, for example, is working really hard on some of the connectivity things. But it really is, we're reliant on our hardware partners to kind of help get that, that last 100 yards out into the cornfield, if you will.
So this conversation around IoT, it's been going on for a long time. And if I'm a big corporation like John Deere or Procter & Gamble, obviously I need to adopt IoT at some point. Like if I wait too long, I'm going to fall behind all the other people who are adopting it. But if I'm too early, then I'm going to aggressively invest in IoT technology that's not good enough. It's not going to catch up soon enough to meet my investment. So how are companies dealing with this problem? Because they must have been burned so many times over the years where they're like, well, we made an investment in this thing that didn't work out because the IoT stuff wasn't as far along as the vendors were saying it was going to be. So at what pace are the big companies, the Procter & Gambles and the John Deeres, how are they adopting the Internet of Things?
So I would say, like most things, that the big companies tend to lag the smaller companies in terms of jumping in with both feet and doing these innovative IoT things. But I would also say most large companies now are at least in the R&D state. They've re-entered if they've been trying to do it in the past. They've kind of aggressively re-entered the R&D stage of IoT. So that's really where most customers are. They're in kind of the POC and maybe small pilot stage of IoT, because not only is there technology to figure out, there's value prop as well. What is the business value of doing this versus the cost? And a lot of that is really just now kind of settling in. We're early on. I mean, specifically the group I'm in within Microsoft, we call ourselves Global Black Belts, but the former name that we had last year may be more fitting in that we used to call ourselves incubation. So kind of incubating new businesses, IoT being one of them. And the idea there is we're kind of helping those customers that want to lead the way in doing this. So the large companies, I would probably say at least a third, maybe even as much as half of the IoT discussions I have today are with big companies. So the J&Js of the world and Bank of America's and companies of that size, and a lot of them are moving forward with IoT solutions today. Now, I think the way companies are approaching it today is maybe a little bit smarter and a little bit more appropriate than in the past, in that they are very much insisting on more kind of standardized and open standards type implementations than they have in the past. There have been a lot of proprietary IoT vendors in the past that have locked people in, and they've they have trouble when they spend that much money and then that vendor goes away, or they have difficulties with that kind of stuff. So I would say a couple of things are really helping today. It's most of the IoT vendors, Microsoft included, especially kind of under our new leadership, are really embracing the open standards and open source type implementations for IoT. I know we certainly are far beyond anything that we've done in the past, and even within Microsoft, the IoT group is often leading the way in terms of embracing open source and open standards. So I think that's helping some. The other thing that's helping a lot is cloud, honestly. So I can approach an IoT project with very little investment. I don't have to stand up a large server farm to ingest my IoT data. I go to Azure portal and I turn on IoT Hub. And if it doesn't work out, I shut it down. I only pay for what I use. Same with Stream Analytics, and then similar with our other competitors, our other cloud competitors as well. It's becoming increasingly easy for companies to kind of do these experiments to see if it's going to work the way they want it to work without a big investment. We like to use the term fail fast. So if I got an IoT project that I think is going to really work well, and it's going to give me a good return on my investment, and I can do this project with relatively minimal effort and relatively minimal cost. And if it doesn't work out, I fail fast with very little expense.
Yeah, and you mentioned that the open source, there's kind of a movement towards open standards or open source, and it sounds like the lessons that were learned in the movement towards open source software are being translated to open source IoT, open source, I don't know about hardware, but at least the protocol standards. Basically, the lesson that it's very tricky to figure out what you want to open source and what you want to keep as your competitive advantage. So it's a fascinating tension there. But speaking of competitive advantage, I guess let's close off by talking a little bit about the different IoT platforms. We have Google, Azure, Amazon all competing in this space. Is the IoT space just as tightly competitive as the rest of the cloud areas, or is there a company that is leading the way? Are these companies differentiated? Give me some perspective on the competitive landscape of cloud IoT.
Yeah, so I think it definitely is competitive and getting more competitive every day, particularly because IoT is such a hot buzzword. Everybody wants to be an IoT provider, and in some cases that means taking something existing and branding it as IoT. Even if you look at the Microsoft platform, Stream Analytics. Really kind of predated some of our IoT work. A lot of the other stuff, Hadoop and machine learning and those kinds of things also predated IoT. So we're putting those towards an IoT solution, with IoT Hub really being the new component there. Amazon's doing the same thing, right? They've got a bunch of their existing services. And they've added their IoT Hub equivalent on the front and calling that an IoT solution. So I think the state of the cloud today is that a lot of companies are, they're rebranding existing stuff to make an IoT solution out of it, and kind of making it all try to work together. And then they're quickly trying to add on, really kind of fill holes. They want to fill holes where they don't have solutions today, either whether that's via acquisition or via internal innovation. So the first stage was really rebrand what we have, and then everyone is running wide open to try to have that complete solution. And I think we're probably one of the few that really has a pretty much end-to-end solution for IoT. The competitor that I personally run into the most out in the wild is Amazon, and they have a pretty good solution as well. I think we kind of have different focuses. They focus more on their existing ecosystem of AWS developers, of which there are a lot of them, whereas we focus on time to market and getting a solution to market quickly with what we call our pre-configured solutions and things like that. But in terms of cloud computing, everyone is taking their existing technologies and putting them towards IoT, and then aggressively filling the gaps. So, if you look at IBM, for example, their IoT solution is primarily wrapped around their Watson artificial intelligence engine. So they're very much into the back-end analytics processing, and they've got a lot of holes on the front end that they're working to fill. If you look at someone like ThingWorx, for example, they are really good on the device side. Their device management capabilities are really good. And really good on the device connectivity side as well, but they're kind of lacking in the back end from a cloud perspective. So everyone's kind of aggressively looking to fill their holes to be able to enable that end-to-end solution. Today I would say Microsoft and Amazon are the furthest along in that journey, primarily because of the existing cloud assets that we have.
Steve, thanks for coming on the show. This has been a great conversation.
Yeah, no problem. I appreciate you having me.